Alright, boys and girls, let's take a look at problem number 5. The laser used to read information from a compact disc, CD, has a wavelength of 770 nanometers. So lambda is 770 nanometers. Alright, which if I put it in scientific notation is going to be 7.70 times 10 squared nanometers. Now, if I know I'm going to need this in meter units, and you'll see why in a second. But how do I get from nanometers to meters? From nanometers to meters, that's 9 jumps, and I'm going up the list, so I'm going to subtract from the exponent. So if I subtract 9 from 2, I get -7. That would be meters. All right, so I'm going to end up needing this particular bit of information when I start plugging into the formulas. All right. Now, we're asked here to compute the energy. Energy equals H nu. All right. This is the equation that allows you to compute energy based on the frequency. But I don't know the frequency. I know the wavelength. However, we know that the speed of light is wavelength times frequency, which means that frequency is equal to c divided by lambda. I just do a quick little conversion here. Now, if I remove the Greek letter nu, the frequency, from this energy equation, and instead of putting nu in, I substitute c over lambda, I create a new equation, hc over lambda. Right? So you may want to copy this in your notes. There are 2 different equations I could use for computing energy. One requires me to know the frequency. The other one requires me to know the wavelength. It is this guy right here that I'm going to be using in this particular case. All right, hc over lambda. If E equals hc over lambda, what is h? H is Planck's constant, never changes, 6.626 times 10 to the minus 34 joules times seconds. All right. Now c is the speed of light, which is 3.00 times 10 to the 8th meters per second. All right. And now the wavelength is going to be in meters, 7.70 times 10 to the minus 7 meters. Now let's very closely take a look at the units, because this is really where you'll make or break your calculations. I have a seconds here and a per second here. Seconds on top cancel with seconds on bottom over here. Now notice the speed was given in meters per second. Right, the meters part here will cancel with the meters part down here. All right, leaving you solely with units of joules, which is exactly what you need if you're computing energy. Energy has units of joules, so the seconds have to cancel, and more importantly, the meters have to cancel. Well, how did I get the meters down bottom? Now, that was all this mess here at the very beginning, where the wavelength in nanometers was converted to the wavelength in meters. And so, going and putting these 3 numbers in our calculator, we will get an answer of 2.58 times 10 to the minus 19 joules. And that's it for number 5.